Hi there, welcome. This is Middle School Math with Dr. K, and today we're talking about calculating slope given a table of values. So there are three kind of significant ways to find the slope of a line. You can do so on a graph, you can do so if you're given 2 points on the line, and you can also do so from a table of values. I do have videos on all three styles, so I'm going to drop the other two videos here if you need them. However, if you're really looking for a table of values, this is your video, and I'm glad you're here. So let's remember what slope is before we go about calculating it. The slope is the change in the line, the height of the line. So as x moves along, as my x values move along, how is my height changing? Is it increasing more? Is it increasing less? Now, sometimes we look at the graph and we kind of think of it as stair steps. So is it increasing by 1 for each unit of x? Is it increasing by 2? Is it increasing by 3? Is it increasing by half? Or is it decreasing for each unit of x? Now, this line that you're seeing here, the pink one, has a slope of 1. That means it's increasing one value of y for each change in x, and that's going to be a comparison point for us throughout this lesson. Now, when we're looking at a table of values, the same is true. I want to know how much is y changing for each unit of x. And I can see that in this table a little bit. So I'm going to look at my values and see how much y is changing. I see that in this case, it's increasing by 5 each time. Now, seeing that pattern in the y values is great, but we have to look at the pattern in the x values also because it could change what our slope is. In this case, it doesn't because the x value is increasing by 1 each time. Now, to calculate the slope, we're really looking at how the two change together. So I want to know the change in y, and I want to compare it to the change in x to figure out how is y changing as x increases each unit. Now, in this case, the change in y is 5, and the change in x is 1, which means that my slope for this line is 5. Now think back to that line we were just looking at. It had a slope of 1. It's kind of a perfect example because it's a just like perfect diagonal line. A slope of 1 goes from one corner of the graph to the other beautifully. Now that had a slope of 1. A slope of 5 means that my line is in fact steeper than that line. So my line might look something like this and be a steeper line because it has a higher value. Let's look at another. Now, once again, I'm going to look at my change in y, and I'm going to compare it to my change in x. And that's what the slope really consists of. I want to know how is y changing as x moves along. So my change in x might be 1, like in the last example, or it might not, and I need to compare those two values. So for example, in this table, I see that my y changes a little bit sporadically. It changes by 2, but then it changes by 4, and then it changes by 8. Now that doesn't mean that this isn't linear. It doesn't mean that we can't find the slope. It just means we've been given some kind of random points on this line that maybe weren't exactly in a pattern. Now the x values change somewhat sporadically too. It increases by 4, then it increases by 8, then it increases by 16. It's changing pretty significantly. Now to find the slope, again, I'm looking for the change in y as compared to the change in x. And because I've got some different values, I'm going to look at it a few different times and see if they come out the same. If they do, then I know this table of values represents a line or a linear relationship. Now the change in y in between my first two rows is 2, and the change in x is 4, which I know simplifies to 1/2. In the next two rows, I can see a change in y of 4 and a change in x of 8, which again simplifies to 1/2. In the last two rows, I see a change in y of 8 and a change in x of 16, which simplifies to 1/2. And that tells me, of course, that the slope of this line is 1/2. Now, what does that mean for my line? That means it's not increasing very quickly. If we go back to our original line, the one with a slope of 1, the one that is beautifully diagonal and goes from corner to corner, if I have a smaller slope, that means that this line is increasing much more slowly, so it might look something like this. If I were to interpret that in words, that means that my y value is increasing by a half of a unit each time my x increases by 1. So it's going up by a half for each change in x, or my stair steps, like in that first example, would increase by 1/2 each time. Here's another example. Again, the numbers are kind of changing sporadically. I'm still comparing my change in y to my change in x, and that's always going to be the case for slope. So you're always looking at the change in y compared to the change in x. So here I can see that my line is actually decreasing this time, so I'll write that as -8. Then it decreases by 12, and then it decreases by -4. Remember, that doesn't mean this isn't a linear relationship. It just means the points we were given are a little bit mixed around on this line. Now my x value is still increasing. It's increasing by 2, then by 3, then by 1. So I'm going to look at all 3 of these comparisons and see if they all come out the same. They should, in a linear relationship, always equal the same thing. Now, realistically, you might not use each change in y and change in x to compare. If you're told you have a line, you don't need to look at all 3 situations. But for the purposes of showing you how this kind of sporadic looking table creates a consistent slope, I want to show you all 3 situations. Now, remember, we're comparing the change in y to the change in x, which in this case gives me -4. If I do it again, change in y over change in x, I get -4 again. That's a good thing. If I compare my change in y to my change in x, I get -4 again. Obviously, that means my slope is -4. Now, once again, I want to go back to that original line because it's kind of easy to tell if you have a positive slope. The bigger the number, the steeper the line. When we had a fraction less than 1, we had a flatter line. But what would a negative line mean? Now remember, that first line had a slope of 1. It went from corner to corner. A slope of +4 would make for a steeper line, right? So if it was +4, it might look something like this. However, a slope of -4 is still steeper. It's just going in the opposite direction. So a -4 slope is a line that's decreasing in value, just like the y values were decreasing in value, but it is a steeper line than 1, just decreasing instead of increasing. Here's one last example just so you can see another variation of slope. Now hopefully you're noticing right away that my change in y is pretty easy to calculate. We're still going to look for the change in y, and we're still going to compare it to the change in x. And I can see from the table that the y is not changing. It's +0 each time. Now again, that doesn't make this not a linear relationship, but it is a very specific kind of line that we're looking at. Now my x value is increasing by different amounts each time, and even a half a point between the last 2 rows of this table. Now, when I calculate my slope, I'm going to get the change in y as 0 each time. So it's 0 over 15, it's 0 over 9, and it's 0 over 18.5. Now, what does that mean? Hopefully you know that you can't divide something by 0, but in this case, I'm dividing 0 by something else. And if I have 0 of something and I split my 0 things into 15 groups, I still have 0 things. If I have 0 of something and I try and split my 0 things into 9 groups, I still have 0. 0 divided by anything is 0, which tells me that the slope here is 0. Now again, remember, this doesn't mean it's not a linear relationship, but it is a very specific kind of line. So the line we looked at in the beginning had a slope of 1. You've heard me say it over and over and over and over and over. It was a perfect diagonal line. What could a slope of 0 mean? Now remember, we're looking at how the line is rising. Is it rising at all if it has a slope of 0? No, that means this line is actually a horizontal line. Horizontal lines have a slope of 0, and they have a slope of 0 every single time, no matter if it's a horizontal line that's up high or a horizontal line that's down low. They all have a slope of 0. That means they are not rising at all. Okay, so that's a really quick rundown on slope and a few different examples of how you could find the slope given a table. Remember that you're comparing the change in y to the change in x. Now, some people like to remember it in this way. You're looking at the rise and the run. The rise would be the change in y value. The run would be the change in x value from left to right. If that helps you, rise over run could be a shortcut way to remember the change in y over the change in x. Now remember, if you're looking for more help, I do have 2 other video tutorials that can help you calculate the slope from a graph and given 2 points on that line. Otherwise, I'll see you next time. Thanks so much for being here.